Hello everyone, welcome back. Before we start, I want to ask you a question. Have you ever wondered why YouTube loads videos instantly, but some smaller websites are so slow to load the same kind of content? Is it just because YouTube has deep pockets and deploys tons of servers? Well, the answer isn't that simple. While YouTube does have plenty of money and servers, the real secret lies in CDNs, caching, and various web acceleration technologies. Today, let's break down what actually happens behind the scenes when you open a web page or watch a video. First, let's imagine an extreme scenario. What if there were no acceleration technologies at all? Picture this, you're in the US, and a video server is in Tokyo. Your request has to climb mountains and cross seas, traveling through undersea cables to reach Tokyo's data center. After the data center processes it, the response has to make the same trip back. It sounds like it's just a bit farther, right? But there are actually big problems hidden here. First, you'd be stuck with huge latency. We know internet transmission is close to the speed of light, which seems fast, but along the way, the data has to pass through countless nodes, like routers and switches, and you also have to account for network congestion and server processing time. To put it simply, it's like shouting to a friend across the Pacific Ocean. Not only is your voice faint, but it also has to take many detours. So in practice, if you're more than 1,000 kilometers away from the server, the latency would be so frustrating that you'd probably just close your computer. Second, a single server would crash easily. Maybe you've built a simple system before. Even if all its features work stably, once more and more people start using it, the server will definitely crash. The reason? Every request floods straight to the server and the server can't keep up. The server's CPU, memory, disk I/O, and network bandwidth are all single-point bottlenecks. No one is there to share the load. Let's use a simple analogy. Think of the server as a fast food restaurant. A restaurant with 100 megabits per second bandwidth is like having only 10 order windows. Then suddenly, 1,000 people show up, each ordering a big burger, a 1 megabyte image. The instant bandwidth needed would be 1,000 megabits per second, 10 times the maximum capacity. There's no way the restaurant could handle that. In the end, everyone would see failed to connect to server when they try to open the page. On top of that, there's another hidden problem. Do you notice it? Wasted repetition. Take a 1 megabyte image, for example. Every time someone requests it, the server has to serve it up all over again. It's like a chef making the same burger 1,000 times a day. How could they not get tired? So without acceleration technologies, you'd end up with high latency, frequent server crashes, wasted resources, slow transmission, and more. That's why the single server serving users worldwide model became obsolete long ago. But luckily, we have acceleration technologies. You've definitely heard of CDNs. CDN stands for Content Delivery Network. If you had to sum up what a CDN is in one sentence, what would it be? The core idea of a CDN is to put content as close to the user as possible. How does it do that? It builds a global distributed network of edge servers. It doesn't replace the original server. Instead, it acts as a front-end distribution network for the origin server in charge of storing and delivering static content like images, videos, CSS, and JavaScript files. In simple terms, a CDN stores static content on its own servers and places those servers close to users. So when you request web page content, you get static files from the CDN. This eases the load on the origin server, and since the CDN is nearby, latency drops. Imagine this, you don't have to fly to Tokyo to buy a burger. Instead, there are branches in New York, London, and Shanghai. You just walk a few blocks and you get your burger. That's what a CDN does. Its actual working principle is straightforward. When you type in a URL, the DNS, domain name system, routes your request to the CDN edge server closest to you. If the server has the content you need, it sends it to you right away. If not, it fetches the content from the origin server once, stores it locally, and then sends it to you, so the next person who needs it can get it directly from the CDN. That's how YouTube uses its global distributed nodes to put content right at your doorstep. This completely solves the problem of long-distance transmission and takes a huge load off the origin server. For example, if you're in New York and open a YouTube video, that video doesn't come from YouTube's headquarters server in California, it comes from the edge node closest to New York. YouTube has deployed thousands of CDN edge nodes around the world. This cuts data transmission latency from hundreds of milliseconds down to just a few. But CDNs don't work alone. They have a trusted partner, caching. Caching is everywhere. Whether it's hardware or software, you'll always find caching. Why? Because it's really useful. Think of caching like frozen dumplings in your fridge. You don't go to the supermarket to buy fresh-made dumplings every time you want them. You stock up, and when you're hungry, you just take some out. Caching on the internet works the same way. We can split caching into 3 layers. First, browser caching. This stores a website's static resources like images, CS files, and JS files in the browser's local folder on your computer or phone. It's the closest caching layer to you, so it's also the fastest. When you visit a website again, your browser sees it already has the site's images, CSS styles, and JS scripts downloaded, so it doesn't need to re-download them from the server. That's why the second visit is much faster than the first. Next, CDN caching. Companies like Cloudflare and Akamai, major CDN providers, store static content in their edge nodes around the world. This is a middle layer cache close to you, and it handles cross-continental access needs that browser caching can't cover. They proactively push core static content to their CDN nodes. This way, when you access the content, you don't have to interact with the origin server over and over, greatly reducing the origin server's load. Finally, reverse proxy caching. This is deployed in reverse proxy servers in front of the origin server. It's a backend cache farther from you. It stores dynamic content or frequently accessed static content, and its main job is to solve the origin server's repeated computation problem. On the server side, tools like Nginx and Varnish cache popular content. Even if there are thousands or tens of thousands of concurrent requests, there's no need to reprocess each one by querying the database. Content is fetched directly from the cache, so responses are super fast. Okay, CDNs plus caching solve most problems, but sometimes that's still not enough. That's where edge computing comes in. So what is edge computing exactly? Here's the definition from Wikipedia. Edge computing is a distributed computing architecture that moves the computation of applications, data, and services from central network nodes to edge nodes in the network. In plain language, edge computing takes the computing work that would normally happen on a faraway server and does it on nodes closer to you, like a nearby cell tower or small server. This makes data processing faster and your internet experience smoother. It's like a takeout restaurant, not just delivering ready-made meals, but also prepping some parts of the food in a kitchen near your home. Its core logic is, let computing follow the data. Not all data processing has to be done on the origin server. Instead, it can be handled by small nearby nodes. Tasks like video compression, security checks, and pre-processing dynamic requests can all be done at edge nodes. Only the final results are sent back to the origin server. This way, data doesn't have to travel long distances, so speeds are naturally faster. You might be thinking, this sounds great, but does it actually work? Let's look at a few real-world examples. YouTube and Netflix, the two biggest video platforms in the world, both have deployed thousands of CDN nodes globally. The videos you watch almost always come from the cache of a local node, not an origin server halfway across the world. This is the core reason their videos load instantly. You definitely know Steam. When you download games, you often get full bandwidth speeds, and that's thanks to CDN nodes too. Steam has CDN nodes in countries all over the world. In some regions, it even partners with local internet providers to put game installers directly in the provider's local data centers. This drastically shortens the data transmission distance. Cloudflare, a well-known CDN provider. It has over 300 edge nodes worldwide. Many small and medium-sized websites use Cloudflare's CDN services. Even if their own servers aren't very powerful, they can still get instant loading for their web pages and keep access stable. All these examples have one thing in common. They bring data closer to users to solve cross-continental latency, use caching to cut down on repetition, and use edge computing for real-time adjustments, all to boost stability. So whether a website loads instantly doesn't depend that much on how much money a company has or how many servers it has. The real key is the underlying technology, CDNs plus caching plus edge computing. These work quietly behind the scenes to save you time and ensure a smooth experience. Next time you click on a web page and it loads instantly, take a second to think. You're not actually connecting to a faraway origin server, you're connecting to a small nearby node. If today's content helped you understand how website acceleration works, don't forget to like and subscribe. Also, feel free to leave a comment and tell me, do you think caching is more like frozen food in the fridge or photos in your phone? See you next time.